More examples here. I have 4 figures drawn here, and we're going to talk about them in pairs to decide if they are similar. A, B, C, D, and E, F, G, H. Are they similar? So similarity means 2 things. Angles congruent, sides in proportion. A, B, C, D. Are the angles congruent when we match them all up?
Yeah.
Yeah, they're all 90, so they all match with each other. Are the sides in the same proportion? No. If we compare the tops, we'd get a 5 to 4. If we compare the lefts, we'd get a 5 to 2. So the sides are not in matching ratios, so those 2 figures are not similar. 2 things. Angles must be congruent, sides must be in proportion. A, B, C, D, and N, O, P, Q. So the first one and the last one of the 4 drawings. Are the sides in proportion? Yeah, 5 to 6 all the way around. Are the angles congruent? No. We have an 88 matching with a 90. That doesn't work. A, B, C, D, and J, K, L, M. So the first figure and the third figure. Are the sides in proportion?
Yeah.
Yeah, 5 to 3 all the way around. Are the angles congruent?
Yeah.
I didn't draw real great. Those boxes look pretty rounded. I intended all of these in JKLM to be nice kind of corner boxes there. So yes, the intention was that we would have all right angles as well. My drawing was a little sloppy. And the final question, JKLM and NOPQ, the last 2 figures, are they similar? Why or why not? Sides work. We have the same ratio, but angles don't. And one of those is not good enough. They both have to be true. So those 2 figures are not similar. So if corresponding angles in the 2 figures are congruent, are the 2 figures similar? If the corresponding angles are congruent in the 2 figures, are they similar?
No.
Why not?
Because there could be something.
There could be something wrong with the sides. Okay, so maybe, but not definitely.
Low?
It's a
Oh, it's an N.
N. If corresponding sides are in proportion, are 2 figures similar?
Yeah.
No. Yes. No. You don't know the
Let's put a reason. We don't know the angles. So maybe, maybe not. So not definitely. Perhaps. So if we're thinking of like always, sometimes, never questions, this would be a sometimes. If 2 figures are similar, are the 2 figures congruent to each other? If 2 figures are similar, are they congruent?
No. Similar, but not the same.
Yes.
What does it mean for 2 figures to be congruent to each other?
Everything's the same.
Everything's the same. All the sides match, all the angles match. So if 2 figures are similar, are they congruent?
Yes.
What matches?
The corresponding angles.
Corresponding angles will be congruent.
Corresponding sides.
What about the sides?
Corresponding.
Are they congruent?
They're in proportion.
They're in proportion. So they're not necessarily congruent to each other. Like if I make a blueprint of this room, the blueprint is not congruent to this room because it's not the same size as the room. The angles are congruent, but the sides are not. There's a relationship between them. They have this scale factor, but they're not congruent. The blueprint is not the same size as the actual figure. Okay? So similarity does not mean congruence. If 2 figures are congruent, are they similar?
Yes.
What does it mean to be similar? We need angles to be congruent. If 2 figures are congruent, are their angles congruent?
Because similar means one bigger, one smaller.
If 2 figures are congruent, are their angles congruent?
Yes.
Yes. If 2 figures are congruent, what do we know about their sides?
They're the same.
The sides are congruent. So if they're congruent, are they in proportion? what would the proportion be? What would the scale factor be? 1 to 1. So it's not an exciting scale factor, but it would work. If two figures are exactly congruent to each other, they are also similar because their sides are in a ratio of 1 to 1. The last question says, are all regular pentagons similar? So a couple of vocab words we need to remind ourselves of here. What does pentagon mean? 5 sides. What does regular mean?
4 sides. 3 sides. 2, 1.
I'm finding it.
Regular was a while ago. I think it was like back chapter 3 maybe we talked about regular. What's regular mean? Congruent sides and congruent angles. In a regular figure, all of the angles will be congruent and all of the sides will be congruent. So if we're talking about like a 4-sided regular thing, that would be a square. All the angles are 90, all the sides are the same size. So regular means all the angles are the same, all the sides are the same. So if I have a 5-sided regular, a pentagon that's regular, would it be similar to another regular pentagon? Would all of the angles be congruent?
Yes.
Yeah. Would the sides be in proportion if they're all the same in one and all the same in another?
Yes.
Yeah. Like if they're all 3 in one of them, all 5 in another, we'd have a ratio of 3 to 5. So when we compare two regular figures, they are going to be similar to each other. So two regular triangles will be similar to each other. Two regular hexagons will be similar to each other. Are two regular polygons then always similar to each other? Why not? What did I say? I asked, are two regular polygons? What's polygon mean? Poly means many. So many sides. Did I tell you how many sides they had?
No.
Okay, so if I just asked you, are two regular polygons similar, I could be talking about a regular 5-sided and a regular 7-sided. Those aren't going to match because I don't have the right number of sides to match up. And one more set of questions for you here, and this is similar to the example that we did in the notes together, but now I want you to give it a shot on your own before you go and give your homework a shot. So these two figures are similar, and I have some questions about them. In the picture, there's some things here that are just not very clear. So let's work on kind of clearing up some of these things. I've got a J here, a U. Down at the bottom, this is not clear. It's a 15. Okay, I think everything else is fairly clear, but I'm going to go ahead and shut off the lights as well so that you'll be able to see this a little better. So take a few minutes, work through these questions, and then we'll talk about them together. How big would angle Y prime be? How big is angle Y prime? 70. How do we know? It says angle Y is 70. How do we know angle Y prime is going to be 70? Similar figures have corresponding angles congruent. So the one is in the first figure should be the same in the second figure. What about angle D then? 90. Again, we look for the matching angles, and they should be congruent. Scale factor of JUDY to the same figure but the primes. When it tells us which one comes first, we want to try to do our proportion in that order. So I think some of you might have done this one upside down, which you'll get the same answers for part C. But when we're saying scale factor of one thing to the other, we want to match the order there. So we're going to say JUDY will be the top of our figure. And then the second one would be the bottom of the figure. Which sides could we use to find the scale factor? The bottoms, we know both numbers for. So we would say that it is 20 over 15 and reduce that down to 4 to 3. So if you had 3/4 on this, you're going to get all the right answers on part C as long as you did everything right there. But when it says scale factor of one thing to another thing, the first thing should come on the top of the fraction. For the next one, we're asked to find then some missing parts. We're going to use this scale factor, 4/3 equals. Then we're looking for side du. Should du go on the top or bottom of this proportion? On the top, because it matches with, it's in the first figure, which we put on the top of the triangle. What does it match up with in the second figure? The 6. Cross multiply. We get 24 is equal to 3 du. So du should be equal to 8. Then for the next one, we do the same scale factor, 4/3 equals. This time we're looking for y prime, j prime. Is that going to go on the top or bottom? Bottom. And what matches with that to go on the top? 28. We're going to cross multiply and divide out. And this time we should get 21. 84 is equal to 4 times y prime, j prime, and then divide out to get 21. For the last one, we're going to do 4/3 is equal to, we're looking for j prime, u prime. Does that go on top or bottom? Bottom, because it's the prime, j prime, u prime. What does it match with? 12t. Because there's a variable in there, that means there's going to be a variable in our answer. We don't know what t is, so it's just going to tag along in this question. So when I cross multiply, I'm going to get 4. J prime u prime is equal to 36t. And divide by 4 gives me 9t. And that t is just going to hang out in our answer. In your homework, there's going to be a question that has a square root of 3 in it. A square root of 3 is not a pretty number. So treat that square root of 3 just like we treated this t, and let it just kind of tag along in the problem. Okay? We don't do anything with it. It just kind of keeps on tagging along. What is the ratio of the perimeters of the figures? Well, we can't actually find what the perimeters are because we have those t's in there. So we don't know what the perimeters are. But what are the ratios of the perimeters going to be? The same as our scale factor. The ratio of perimeters will be the same as the scale factor of the figures. And the last question says, why does dujy not create a similar figure to y prime, j prime, u prime, d prime? So in other words, why does the order of the letters matter? Why can't I just shuffle around the letters and name them whatever I want? What does the order of the letters tell us? It tells us what angles should match with what angles. So when it's written this way, that means that angle D should be matching up with angle y prime. In the picture, how big is angle D? 90. How big is angle y prime? 70. That's the answers that we came up with in part A. Those are not the same. So when we name our figures, we can name the first one whatever we want. But the second one, we need to make sure that we're naming according to the first, so that matching things are in matching places of the name. So the angle that matches with D would need to be the first thing that comes in the second name. Okay? So we can name the first one in any order, but the second one needs to be named so that it matches with the first one, because the order of the letters tells us about the figures and what's supposed to correspond to what. Questions on similar figures? Your homework tonight is from lesson 7.3.